Today, we're diving into this secret life of data. It's this invisible engine that's running pretty much everything in our digital world. Seriously, from the apps on your phone to massive scientific breakthroughs, it all comes back to data. But how do we get from just a messy pile of information to these incredibly smart, world-changing AIs? Well, let's get into it.
So, let me just start with a quick question for you. What on earth could your music recommendations have in common with, say, a mission to Mars? I mean, it sounds completely random, right? But they actually share a secret ingredient. And that secret is high-quality, well-managed data. Without it, your playlist would be a total disaster. And that rocket, yeah, it would literally never leave the ground.
So where does a journey like this even start? Well, it all begins with what you could call the great data hunt. You got to think of it like prospecting for digital gold. We have to venture out into this vast digital universe to find the raw materials that are eventually going to fuel all our big ideas and innovations.
And here's an analogy I absolutely love. Raw data, all by itself, is kind of like crude oil. You know it's packed with potential. It's incredibly valuable. But you can't just pump it straight out of the ground and into your car. Nope. It has to be discovered, it has to be extracted, and most importantly, it has to be refined before it becomes that high-octane fuel that really powers artificial intelligence.
So, where do we find these digital oil fields? Honestly, they're everywhere. Data gets collected from an unbelievable number of sources. You've got these huge public portals like data.gov, which is just full of information from all sorts of government agencies. Then you have scientific hubs like what NASA puts out. And of course, there's the constant, real-time stream of human experience pouring out of social media like Twitter and all the apps we use every single day.
But not all data is just floating around out there on the web for the taking. A massive amount of it is actually kept neatly organized inside databases. And for that, we don't just scrape it off a website, we have to ask for it directly. We use something called a query, which is basically a very specific request to pull out exactly the information we need. It's a much more precise way to hunt.
Okay, so we've got our raw material, we've prospected for our digital oil, but how do we make it smart? This next step is all about giving that data a brain. And believe it or not, it actually requires a very human touch. This process is called data annotation, and it's pretty much exactly what it sounds like. We are literally labeling pieces of data to teach a machine what's what. Think of it this way. You can't teach a toddler what a dog is just by showing them 1,000 photos. You have to point to one and say, that's a dog. Data annotation is us, humans, pointing things out for the AI.
And this right here is that human touch in action. Now, it might look pretty simple, but this process, a person manually drawing boxes around things and assigning labels, telling the algorithm, this is a car, this is a pedestrian, this is the incredibly detailed, essential work that builds the entire foundation for some of the most complex AI systems out there.
And this whole labeling thing, it actually takes a few different forms. The simplest is image classification. That's just answering, does this photo have a cat in it? Yes or no? Then you get more specific with object detection, which is what we just saw. That's asking, okay, where in the photo is the cat? But then you can get way more detailed with something called semantic segmentation. Now, instead of just a box around the cat, this process labels every single pixel that belongs to the cat. This is the tech that lets a self-driving car tell the difference between the road, the sidewalk, and another car with pixel-perfect accuracy.
All right, so we've collected our data, we've painstakingly labeled it, we're ready to build our AI, right? Well, not quite. Turns out, not all data is created equal. We have to do a really tough quality check to make sure our refined digital oil isn't contaminated. And the one big question we have to ask is this: is this data actually fit for use? And this definition, it's so simple, but it is everything: fit for use. It means that quality isn't some abstract, perfect ideal. No, it's completely dependent on the job you need that data to do. The kind of data you need for financial accounting has a totally different quality standard than the data you need to recommend movies. The purpose is what defines the quality. And the stakes here? They couldn't be higher. On one side, you've got the goals. You want data that's relevant, accurate, timely, and complete. Get that right, and you are set. But on the other side, you see what happens when you get it wrong. Lower customer satisfaction, a total lack of trust in the organization. I mean, when people can't trust the data, the entire system just starts to fall apart.
So let's break down what these properties actually mean in the real world. First up, relevance. Does this data even help with what we're trying to do? Then, accuracy. Are the details correct? Is it right? Timeliness.
Is this data current enough to be useful right now, or is it old news? Completeness. Are we missing huge chunks of information? Are there gaps? And finally, comparability. Can we mix this data set with other data without creating a complete and utter mess? You've really got to hit the mark on all 5 of these.
This all leads us to one of the oldest, most important rules in all of computing. Garbage in, garbage out. It means that no matter how brilliant your algorithm is, if you feed it junk data, you're going to get junk results. End of story. Imagine a retail company using sales data to figure out what to stock for the holidays. If that data is wrong, maybe it miscounts returns or totally misses a region's sales, their predictions will be way off. They'll wind up with warehouses full of stuff nobody wants and empty shelves where the hot items should be. So the big question is, how do we avoid the garbage?
Thankfully, there's a pretty clear framework for handling this. It's really a 3-step cycle. First, you've got prevention. You build systems to stop bad data from even getting into your system in the first place. Step 2 is detection. You have to proactively hunt for any bad data that might have slipped through the cracks. And finally, repair. When you find that bad data, you fix it. It's this constant ongoing cycle of quality control.
So why go through all this trouble? Well, because this is the payoff. This is what good data actually lets you do in the real world. It lets an insurance company figure out fair premiums. It lets a business do its accounting accurately. And maybe most powerfully, it lets us build models that can reliably predict what's going to happen in the future. These aren't just abstract ideas. This is the bedrock of modern business and science.
So, I'll just leave you with this one last thought. The route your GPS just gave you, that fraud alert you got from your bank, even the medical advice your doctor gives, all of it is running on this hidden, complex, and absolutely crucial process. So the next time you use a piece of tech that seems just a little bit like magic, ask yourself, what part of my world is running on data that passed the test?